So today we're going to look at day 1 of 2.1, the vertex form of a quadratic function. Today we're going to learn how to use quadratic functions to model situations and solve problems. At the end of today's lesson, you should be able to identify key features of a quadratic function. A lot of this is going to be review, so let's go through this. A quadratic function, so this is a quadratic function, can be written in the form f of x equals ax squared plus bx plus c, where a cannot equal 0. All quadratic functions are transformations of the parent function f of x equals x squared. The graph of a quadratic function is called a parabola. And it is shaped like a U. The vertex form, that's what we're going to focus on today, of a quadratic function is f of x equals a times x minus h quantity squared plus k, where h comma k is the vertex of the parabola. Vertex form is extremely useful because it highlights the vertex of the graph of the quadratic function. The vertex form shows 3 different ways the graph of the function f of x equals x squared may be transformed. The a, the number out in front, determines if the parabola opens up or down and if it is stretched or compressed. If a is greater than 0, which just means if a is positive, the graph opens up. If a is less than 0, which means that if a is negative, the graph opens down. If the absolute value of a is greater than 1, the graph shrinks, or it's narrow, compresses. If the absolute value of a is between 0 and 1, then the graph stretches or becomes wider. H determines the horizontal translation. And again, it always comes out opposite. So if it's an x plus h, okay, it will come out as a minus h, which will shift the graph left. If it's an x minus h, it comes out as x plus h, and it shifts the graph to the right. The k determines the vertical translation. Plus k shifts the graph up. Minus k shifts the graph down. So the HSRV, just like everything that we learned in Chapter 1. The quadratic function is symmetric about the line that passes through the vertex, and this is known as the axis of symmetry. Axis of symmetry. Lots of times you will see us abbreviate this as AOS. So AOS, axis of symmetry. The axis of symmetry, the equation for that is x equals h. So it's just the vertical line, x equals whatever the x value was of your vertex. We will graph this with a dotted line on our graph. If the parabola opens up, there is a minimum value, so minimum value at the y coordinate of the vertex. If the parabola opens down, there's a maximum value at the y coordinate of the vertex. Okay, so let's look at some examples. It asks us to describe the transformations of the graph, HSRV, identify the vertex, axis of symmetry, domain, range, maximums or minimums, and then we're going to graph a few of these. So the first one we're going to look at, f of x equals negative x plus 2 quantity squared. So our a is just 1. Sorry, it's negative 1. The vertex, okay, inside parentheses says x plus 2, so it comes out as a negative 2. So negative 2 comma 0. And we're going to go back to that a, and we're just going to call it a positive 1, since we're looking at the absolute value of what our a is. Okay. All right, h. So it was x plus 2. Vertex was negative 2, so it moved it left 2. Stretch or shrink? Nope. Our a is simply 1, so there's no stretching or shrinking. Reflection? Yes, because it's a negative. Vertical? There's nothing being added or subtracted on the outside, so there's no vertical shift. The domain. This is nice about quadratic functions because remember, domain or x values, what you can plug into the function. Okay? I can plug any number in and square it. So my domain of a quadratic function will always be negative infinity to infinity if they have not restricted it. The range. So I notice that this graph is going to open down. So my y values, I'm starting at negative infinity, and I'm going to the y value of my vertex, which is 0, with a bracket. The axis of symmetry, x equals the x coordinate of my vertex, -2. It opens down, so it's a maximum at the y coordinate of my vertex, 0. So now we want to graph it. Remember that all of our graphs, okay, all of our HSRVs, we start with the parent function. Table of values, -2, -1, 0, 1, and 2. So then 4, 1, 0, 1, and 4. So our new one here that we're going to graph, what's inside parentheses is the only thing that affects the x. So it was x plus 2, so it comes out x minus 2. I had a negative out in front, so I'm just going to have a negative y. So I take all of my original x's from the xy table, from the parent function, and I'm going to subtract 2. So -2 minus 2, -4. -1 minus 2, -3, -2, -1, and 0. And then the y's, all we have to do is change them and make the negative. So -4, -1, 0, 1, -1, and -4. These are the points that I'm going to plot. So -4, -4, -3, -1, -2, 0, 1, parabola. Remember, we're making it the U shape. Now we're going to go ahead and graph the axis of symmetry. It is a dotted line through the vertex, and I'm going to label it x equals -2. So that's our very first one. Now let's look at example number 2. G of x equals x minus 1 quantity squared plus 2. A is equal to 1. The vertex, 1, 2, because it was x minus 1, comes out opposite, and then plus 2 at the end. So the h, okay, it came out as a positive 1, so it shifts the graph right 1. There's no stretch or shrink because our a is just 1. There's no reflection because there was no negative out front. And then the vertical, it's going up 2 because of the plus 2 at the end. Remember, when you're filling out your HSRV, you have to tell me if there's not one, like the S or the R in some way. You can't just leave it blank, or else I think that you're not sure what it is. So you have to some way show me that you know that there is not one. The domain, again, all of our domains, -infinity to infinity. The range, okay, so this graph is going to open up. So that means that the lowest y value was the y value of my vertex, okay, which was up 2, so that's included. So 2, and then it continues on up to infinity. The axis of symmetry, x equals 1, from the x coordinate of my vertex. We'll have a minimum, since it's opening up, at the y coordinate of my vertex at 2. So now we want to graph this one. Going to make a new xy table for this one. On this one, my x is x plus 1, and it's going to be y plus 2. So I'm going to take all of my original x values from the parent function and add 1. So -2 plus 1, -1. -1 plus 1 is 0, 1, 2, and 3. All of my y values, and I'm going to add 2. So 4 plus 2 puts me at 6, 3, 2, 3, and 6. Now these are the points we're going to plot. So over -1 up 6, that's going to be off my graph up there. 0, 3, 1, 2, 2, 3, 3, 6. Again, the U shape. And we're going to do the axis of symmetry, the dotted line, and label it x equals 1. All right, those are the only two that I'm going to graph for you in these notes, because we've been graphing our parabolas in chapter 1, so that part is not really anything new to us. Or now we're adding the axis of symmetry as the dotted line and labeling it. So now let's just look at these examples 3 and 4 and just identify all of this information. So number 3, h of x equals 2/3 x squared plus 15. The a value is 2/3. My vertex, I don't have any parentheses, so there it's not moving left or right any, so it's still 0, and then 15. H, there was no parentheses, so there's no horizontal shifting. Stretch or shrink, okay. it is 2/3, so that means that it is going to stretch the graph or make it wider. R, there is no negative, so there's no reflection. Plus 15, it goes up 15. Our domain, again, negative infinity to infinity. Our range, it's opening up, so I know that I'm starting at my vertex, which was 15 in brackets, and then it's going on up to infinity. The axis of symmetry, x equals 0. It was opening up, so it's a minimum at the y-coordinate of my vertex, 15. All right, so let's look at number 4. F of x equals negative 7/3, x plus 6 quantity squared minus 13. My a is 7/3. My vertex, I have parentheses, it comes out opposite, so it's a plus 6, so negative 6, negative 13. It came out at the h value, it came out as a negative 6, so it moves left 6. Okay, my a value is 7/3. Okay? 7/3 is greater than 1, so it shrinks it or makes it narrow. Yes, I have a reflection because there was a negative, and then it goes down 13. My domain, again, negative infinity to infinity. This one opens down, so for my range, I'm starting at negative infinity is the lowest y values, and then I stop at negative 13 brackets. Axis of symmetry, x equals negative 6. I'll have a maximum because it opens down at negative 13. So a lot of that was review, which is nice. We learned a bunch of this in chapter 1. All right, so next page. Write an equation of a parabola with a given vertex and y-intercept. We're going to write in vertex form and in ax squared plus bx plus c form. Okay, so we're going to do both. All right, so to start out, okay, vertex form, okay, I can go ahead and enter this in. Okay. So my vertex form, I get, right now I would have y equals, I don't know what my a is, so I'm just going to put a, and then x, it's a negative 2, so that would have been a plus 2, quantity squared plus 3. I need to find out what my a value is. So now I'm going to plug in the point, y-intercept of negative 1. That means the x is 0, the y is negative 1. I'm going to plug those in for x and y into this equation and solve for my a. So y, negative 1, equals a. Instead of x, I'm going to put 0. So I have 0 plus 2, quantity squared plus 3. I'm solving this for a. So I'm going to subtract 3 from both sides. So I have negative 4 equals 0 plus 2 is 2. 2 squared is 4 equals 4a. Divide by 4, I get a is negative 1. So the vertex form is f of x equals negative parentheses x plus 2 quantity squared plus 3. Now we want to expand that out and write it ax squared plus bx plus c, which basically just means this x plus 2 quantity squared, we're going to FOIL it. Okay? There's a shortcut to FOIL when it is quantity squared. The shortcut, okay, you take the, so this is FOIL for my shortcut. So the shortcut, you square the first term, then you multiply the two terms together and double, and finally square the second term. Okay. So let's see how that's going to work. So I will have f of x equals, I have the negative out front, so I'm going to put parentheses. So my shortcut says I square the first term. My first term is x, so x squared is x squared. And it says I multiply my two terms together. X times 2 is 2x, and then I double it. So 2x and 2x plus 4x. And then finally square the second term, which is a 2. 2 squared is 4. Close my parentheses, and then I have the plus 3 at the end. I need to distribute my negative, so I get negative x squared minus 4x minus 4. The negative does not go with this 3, so plus 3. So now I just want to combine like terms, so I would have f of x equals negative x squared minus 4x negative 4 plus 3 minus 1. So there is the ax squared plus bx plus c form. This is the vertex form. We're going to do one more of those, and then that's where we are stopping at day 1 of this lesson. So the vertex is 1, negative 4. So I write y equals a, because I don't know that yet, parentheses, x minus 1, quantity squared, minus 4. At the point negative 2, negative 1. So at negative 2, negative 1, so I'm going to plug negative 2 in for x, negative 1 in for y, and solve for a. So I'm going to have negative 1 equals a, parentheses, negative 2 minus 1, quantity squared, minus 4. Add 4 to both sides, so here I get 3 equals, negative 2 minus 1 is negative 3, negative 3 squared is 9, 9a. Divide by 9, so I get a is 3 divided by 9, simplifies to 1/3. So now vertex form, f of x equals 1/3, parentheses, x minus 1, quantity squared, minus 4. So that is my vertex form. Now I'm going to do my shortcut instead of FOILing this out. So I would get f of x equals 1/3, parentheses, my shortcut, the first term squared, x squared. Multiply the two terms together. X times negative 1 is just negative x, but then I double it, so I have negative 2x. Square the last term, negative 1 squared plus 1. And then I have negative 4 at the end. I need to distribute my 1/3 with everything inside parentheses, so I get 1/3 x squared minus 2/3 x plus 1/3, and then minus 4. So now I'm going to just come over here, combine like terms, so I get f of x equals 1/3 x squared minus 2/3 x, 1/3 minus 4. Okay. I could write that as a mixed number or a fraction. So if I look at my fraction, that's 1/3, common denominator. So this is really 12/3. So 1/3 minus 12/3 minus 11/3. So that is the other form of this. That's all that we're going to do for the first day. Tomorrow we will look at the word problems and writing the equations from a graph.